Hi, my name is Louisa, and welcome to our research plan poster for a study investigating short-term memory for pain. And we're planning to conduct a transcranial magnetic stimulation study to do this. The ability to temporarily retain a stimulus that is no longer perceptually present characterizes our sensory working memory. For example, retaining information regarding stimulus intensity, duration, or location on the body. In the tactile domain, it has been shown that the neural substrates underlying working memory for touch to the skin surface are the same substrates underlying early encoding and detection. Notably, this is the primary and secondary somatosensory cortices. Interestingly, S1 and S2 also subserve the encoding of nociceptive inputs to the skin. However, no study has investigated the extent to which S1 and S2 also underlie working memory for painful touch. And so, in this study, we will use TMS to determine the causal and temporal contributions of S1 and S2 in painful compared to non-painful tactile working memory. Under a between subjects design, participants will receive either painful or non-painful electrotactile stimulation to the left index finger. They will receive 1 second of stimulation, followed by a 1.5 second interstimulus delay, and then a second 1 second stimulation to the same finger, after which they will be asked to identify which of the two stimulations was greater in intensity. Importantly, during the interstimulus delay, we will administer single pulse TMS over either S1, S2, or a control site being the vertex at one of three time points, 300, 600, or 1200 milliseconds. We predict that single pulse TMS over S1 and S2, but not the vertex, will impair discrimination accuracy, but that this will differ as a function of painful or non-painful stimulation and as a function of TMS time point. So for example, stimulation over both S1 and S2 in the pain and non-pain group will impair accuracy performance, but only at 300 or 600 milliseconds and not 1200 milliseconds. This is due to previous suggestion that later working memory is dependent on more executive frontal regions. In the non-pain group, we predict parallel working memory processing across S1 and S2, therefore an equal decrease in performance accuracy by TMS over these sites at 300 and 600 milliseconds. Contrastingly, however, due to suggestive fundamentality of S2 in pain encoding, we predict that TMS over S2 for the painful working memory group will more greatly impair discrimination accuracy than in the non-pain group. Thank you very much for listening.